All right, folks, we're back. This is video 2 on the VFR750F carb. And I want to start this video off by just going over the general information on these carbs. And I hope you don't mind if I read from some notes here, because if I don't, since my brain is half dead, I probably will lose my train of thought and start talking about steam engines or something, who knows. I would say that these carbs are overall quite dirty inside and out. And I'll show you some B-roll, but they certainly weren't the worst. You know, the float bowl gasket surface, this is semi-cleaned in this state. Kind of the crust that was inside these float bowl grooves as far as the gasket goes. But not terrible, not anywhere near as worse as I've seen before on some of the Valks because of that goo that Honda uses to hold the gaskets in. These are kind of apprentice marked up. So I will be testing these with that piece of glass and the vacuum once I change the O-ring out on the drain screw, which you need to do for that. And then we'll test those off camera and make sure they're okay. I'm sure they're gonna be fine, but you never know. I just wanna make sure. So as far as the main carb bodies and the contents go, we'll go over that here. Now the orientation and location of jets and so forth is the same as we've seen on Valkyrie carbs. Enricher jet, main jet, pilot or slow jet, and of course here's where your float valve goes. The main problem with these carbs was, number one, the enricher jets on all 4 carbs, this is a pressed-in jet to number 42, were completely blocked or at least partially blocked. In concert with that, this is the enricher air jet, and the enricher air jet was also either completely or partially blocked on all 4 carburetors. I forgot which one of these two is the other one, but one's a main air jet and the other one is a pilot or slow air jet. Those were fine. But the enricher air jet, I'm 100% sure, is this shorter guy here. And it was, again, almost 100% or 100% clogged. And these were clogged as well. Now, the viewer, I've been conversing with him, obviously, and he said this thing was really hard to start under any condition. And if it was running, for example, and it was already warmed up, he said, and you hit the enricher, it had no effect. And I would say that would be accurate, that would be correct, because these were not functioning whatsoever. I have 100% verified that they are all open now, and I've flowed some brake clean through them and actually visually saw that, so it's pretty good. Okay, so this is one of our number 40 slow jets. Remember, the enricher jet's 42, this is a 40 slow jet. At least 2, if not 3 of these were either all or partially clogged. I would say 2 of them were fully clogged, and 1 was partially clogged, and 1 of them was fairly open. These are the jets themselves, not the jet circuits. Those are fine, or those were fine. But the jets themselves were most definitely compromised, and they are completely open now. There you go. Now you got it. I knew you could do it. So yeah, they're completely open now. So they're in good shape. There's no problems with them other than that. And so we took care of that. Let's go over the reason the fuel joint or joints was or were leaking, depending on how you look at it. I don't know if there were any more, probably, but here's one of the old fuel joints. I've actually already removed it and stuck it back on because when I removed it, they just kind of split like they typically do. But it gives you a good representation that these things were absolutely not sealing at all, because, and I'll show you some B-roll of them prior. It shows it a little bit better. But they're essentially below the surface of the groove. That's why. I mean, they're just completely wore out. You see how flat they are. Now, in contrast, we'll take a look at a new one. This is one of Red Eye Rich's Viton O-rings, which he coats with some moly. It's kind of all wore off right now. I got 4 of these, but I'm not going to use them in this job. I have the originals, but just showing you in concert, you can see how much more proud, I need an MRI, that O-ring is outside the groove as compared to this guy again. So there's your problem, lady. That's the way they're doing it. Now, we're going to go over some fuel T information here in just a moment, but let me finish this part up first. So this is a good segue, since we were talking about fuel T's, into the place that they go inside the carburetors. In other words, these bores that they slip into. Now let's make sure we got the right carb. We do not have the right carb. We need carb number 2, which is not here. Carb number 2, there it is. There, I tell you what, I need 2 MRIs. Here's the problem we have with this number 2 carb body. And we're gonna zoom up on that in B-roll and show you. there's a spot in the carb body as far as where that bore is, and that is where the fuel T slips in. That's got some apprentice marks or some corrosion or both in there. And what I am concerned about is, because of that, I'm concerned about the O-ring sealing on that surface, because it is kind of a little, I'm not gonna call it a gouge, but it sure potentially is that, or just an area of corrosion. And I am again concerned about the fuel T O-ring, you know, really settling in there and sealing it off properly. So this is what we're gonna, well, I'll show you what we're gonna do, but this is what the old one is looking like when you put it in there. So again, same carb bore. I'm not gonna put any lube or anything on them. I'm just gonna shove it in. And so this is one of Red Eye Rich's Vitons, which is basically the same size as the OEMs. And we're gonna put it in, and it's pretty firm. It'd probably work. What I ended up doing was, I ended up machining new ones. And these are they, or this is it. Now, I'm gonna go over the detail on this just very briefly as far as the engineering on this goes. But what I ended up doing was I made these O-ring grooves with two differences from the originals. The first difference is that the original grooves are 100 thousandths wide. And that's, of course, we can't get this thing to focus. But you can kind of see that the original groove on the plastic tees is definitely wider. And I made these 88 thousandths wide, which is what I typically do. The tool is 78 thousandths wide, so it's easy just to bump it over 10 thou on a second cut and widen it out to 88. And 88 seems to work pretty well for these OEM Honda and also the aftermarket, these Viton O-rings. So I did that for two reasons. Number one, because it fits better. Number two, I don't want the O-ring to spread out in there and kind of flatten more easily. I want to kind of restrain the O-ring from deforming and flattening a little bit more than what these originals would, because they're wider. I also made this groove here, the diameter that the O-ring slips over, 10 thou bigger than the OEMs. So that's 10 thousandths bigger on that diameter, and the groove is narrower. And of course the overall T is longer too. I did kind of test fit these together, and I had about a 1/16 of an inch slide back and forth without any O-rings on them. That's the best way to do it. You take the O-rings off, slip one of these guys back in, make sure that the carbs are, you know, pressed together with all the spacers and so forth. So I made this one about 40 thou wider. But anyway, the length is not as important as the girth, so I've heard. So what we're going to do here is we are going to put this in, and I wish I could show you the force, but I don't have any way to measure it. But it's substantially, if not just, well, maybe not substantially, it's got some, you need extra force to push that in. And that's because, again, the O-ring groove's a little bit larger, and the groove is narrower, so it's not gonna distort or displace as easily. And this is what I typically do when I make these anyway. And so what I figure is, if I can put more outward pressure from the O-ring, from where it sits in the groove, out to the inside of this bore, right there, I think we're gonna have a better chance of this sealing in the long run, and it'll conform to that irregularity in the bore and just stay okay for however many millennium that it needs to stay that way. So that's why we did this. And you know, I had to kind of make these, I didn't film any of the machining of this. I did it this way because the way these things work, they slip through the center bracket, which is not in front of me right now. So let's turn it this way. And if we turn this one this way, you may have this going through, or you do have it going through a bracket where this shoulder, this side, closer to the spigot, would be closer to the bracket. And both of them are that way, depending on which one you put it, which side it goes in. One goes in one way and one goes in the other. But they are both, you know, near that center section, because the hoses are fairly close together, where they run from that distribution tee. We'll show you that when we get it all back together. So I made it so this thing should have enough clearance to clear any of that center bracket. And if it doesn't, I can just chuck it up in the lathe real quick and just face this shoulder. This side is nominal. This side's not going to be a problem. That's why it's angled like that. I just used my 45-degree tool. Normally I would use it on both sides, but if I did it on this side, I'll be cutting into where the spigot would have to go, because this has to go pretty close to the shoulder. What I did with these was, even though they are pushed in with 638 Loctite and I got about 1.5 thou crush on them, just because of the shape and the size of the spigot relative to this main body, which I had to cut down because I don't have a lot of real estate in there, I decided to back this up with a little bit of JB Weld. So I just smeared some on a couple nights ago and dressed it up best as possible, let it cure. This is never gonna leak, it's never gonna come out. So I'm real happy with the way they came out, and I think they're gonna work a lot better than the originals. Now let's talk about floats. I mentioned in video 1, the floats have seen better days. They've been around the block a few times. Certainly the part that's not sitting in fuel is better than the part that is. But my experience, these things get real brittle and they're gonna start cracking, microscopic cracks, and they're gonna start filling up with fuel. So I ordered new floats. They're aftermarket and I really like them. They're Too Fast Moto. This is the part number from them, and they reference the Honda part number below it. It comes with a float pin, which is basically meh. It's okay. It's just it's a steel pin with it's zinc plated. I don't really like that. I'll probably use the original, which I think is either stainless or some other higher, like even ground. Anyway, there's the float. Now remember, these are non-adjustable, just like in the Valks, but this thing is this is nice quality, and it is like almost dead nuts exactly the same. I mean, I'm really liking it. I haven't tried one yet. We're gonna go ahead and do that here in a little bit. I'm gonna get all 4 carburetors rebuilt. 3 of the 4 carburetors rebuilt off camera. And when we go to the 4th one, I'll show you that as far as putting it back together, and we'll go over the float level and stuff. In fact, I like them so much, I ordered 4 of them for my Magna. I'm gonna replace the floats in my Magna with these as well. That's how much I like them. So we're gonna move on to one other final thing, which was a little bit of a concern to me, but regarding these fuel tees, I just wanna make it very clear, people might be working on these bikes. There's absolutely nothing wrong with this plastic tee. It's not cracked, it's very strong, it'd probably last 100 years. There's nothing wrong with them. But in this particular case, I was just concerned, again, about the ability for it to seal on that one particular bore. I know what you're thinking, and yeah, I did think about trying to find a slightly larger O-ring just for that one spot. But the chance of finding one that's slightly larger that'll actually fit in there and being a good quality like Viton or other fuel-resistant O-ring is pretty much slim to none. So I just went ahead and made the aluminum ones. But I'll make a drawing, and if anybody needs one or 2 or whatever, I can, like other ones that I have in my my library, I can make them up for you. But again, there's nothing wrong with these. They're just, I think these are just going to do or suit us better in this particular application, I hope. So again, these would probably work just fine for even a long term with new O-rings on it, but I just wasn't sure, and I know I can put a lot more pressure on that O-ring if I make a new one in the manner that I've already described. So yeah, again, there's nothing wrong with using those. All right, last thing I want to cover before we move on is one of these guys. This is a jet holder. That's what Honda calls it. It's a main jet holder. So this is what screws into the car body. Got the little holes. In a normal or typical carburetor, the slide needle would slide down into this area, and it's more of emulsion too, in my opinion, in that case. But in this case, it's just really a jet holder. So your main jet screws into that, and then Bob's your uncle, everything's good with the world. But we found one that had a problem. I guess I did, and I'll show you that in some B-roll here as I talk. The problem with the one I found is that somebody had put this in probably with a wrench and cammed over the edge and essentially broke the edge in, so it had a crack in the very top. So let me simulate that with a wrench. I'll show you what I mean. So this takes a 7mm wrench, as you can see, one without fuzz on it, hopefully. And what I'm thinking happened is somebody's loosening this thing up, and there's probably no jet in it. So they took the jet out, like I was doing in video 1, and then they went to take this off, and it might have been very tight, and they kind of cammed over like this, you know, it rocked over and damaged that edge. Indentation in that kind of crushed area is very similar to an angle that an open-end wrench would present if it was at an angle like this. So that caused me some concern, because I'm going to show you on this, on a good jet. This is the edge that the main jet seals on right here. There's no taper or anything. There's nothing inside there that this thing seals in. It's not the threads. It's this face. So it seals with the bottom edge of that jet. And that's, of course, you know, this guy right here. So these are the two faces that seat to each other and seal each other off. You know, seal to one another, I should say. And that's really of concern to me when there's a crack in that top edge. I went ahead and thought about this. They're not available as far as OEM. Anyway, I'm going to explain the whole thing. I did shoot some clips of repairing this, and these are going to be coming up here forthwith, and you'll see what I mean and how I dealt with this. I will show you the end result right now. The end result is this, which is soldered and cleaned up, and I just touched the face with a tool to square it off, and she's just beautiful. It came out really, really well, and your jet goes in no problem and seats up no problem. So that really solved that. But I'll go over in these clips in detail how I did this and why we just didn't try to get like a used one. There's a couple of reasons why. So let's go ahead and get on with those clips, and then we'll move on from there. All right, so this jet holder is not available, and I'm not surprised about that. So I don't have anything in stock, even though all the carbs I've rebuilt and replaced these things. I just don't have one that matches up to this kind of special. So what we're gonna have to do is we're gonna fix this. We're gonna fix that crack. How I'm gonna do this is, the first thing I need to know is if I can get this thing as concentric as possible on the lathe here on the 3-jaw without setting that little 4-jaw up. I mean, I could do that, but if I don't need to, I really don't want to. So there's a couple ways you can do it. I have the main jet in, and it's not reading very well, which is understandable because these things get distorted from just, you know, using a screwdriver in the slot over the years. So the best way to do it is just to pick up on the jet itself, but the only true surface on this, or at least semi-true surface, is the hex. So there's a couple ways you can indicate a hex in to make sure that it's pretty square, or not square, but true. And we're going to do one of them right here. This is a tense indicator, so it's going to be quite accurate. So we'll pick up about it right there and set a 0, but what you have to do is you have to rock the spin, you have to rock the chuck and find the high spot, or in this case the low spot. So that's 0 on that one. And then what we'll do is we'll get some glare into the indicator. How nice. We just back it up. We're going to move to the next one. Advance the quill on the tailstock, and then we're going to do the same thing. We'll rock it till we get to the low spot, which is about, well, this is a tense indicator, so it reads in ½ thou, so that's 1 thou right there, which is, I'm not terribly happy with, but I could probably live with it. The whole reason is I got to go in here with something and clean that inside up that's bent inwards or deformed inwards, and if I don't do that, then we're going to be kind of screwed. So that's a little over 1 thou. It's 1.5 thou on that one. ¼ thou. So we may need to put that little 4-jaw in and use it as a mechanism to dial this thing in a little bit better. That's 0 as well. Well, let's just do it again and see what we got. I don't know if I'm going to be able to get it any better than that. Let me think about it a second. All right, I went to the little 4-jaw. I can get it a lot closer this way. And I'm going about halfway up so it's consistent. In other words, halfway in. ½ thou low, thou low. Likewise about 1 thou. ½ thou. And dead nuts on 0. So we're within 1 thou. I think that's about the best we're going to be able to get this thing. I just don't like doing it this way because I don't want to damage the main part of the, you know, Honda calls it a jet holder, so I just don't want to damage that part of it. I'm pretty sure these jaws are smooth in there though. Yes, they are. They're not like, you know, like the ones that's holding this little chuck on my, you know, my big chucks. All right, so the whole reason I got to do this, because I got to take it back out and do it all over again, but I got to clean up that inside edge with something that's kind of folded in. And I got to do that very carefully. It's not a taper or anything. There seems to be one inside there. I'll show you a good jet holder to understand what I'm talking about here, because this is going to be a finicky repair here. What we'll do now is I got to take this jet I stuck in there to try to test this out. I'll take that jet out, and then I got to figure something out. I guess I can try to find a used one on eBay, but I tell you right now, you go to find one of these, you have to buy a carb body. Nothing's ever going to match up 100%. Somebody may be selling a bunch of these things, like in a baggie or something. Best way to do it is to probably repair the one we got, or just get another carb body and harvest the innards from it. The best way to deal with this is just use an end mill, because I measured that out and it's 5 mil. And it just so happens I have a brand new 5 mil end mill. We can put it right into the drill chuck and just go in here and use the, we'll use the quill on the tailstock to control it. And we'll just go in there and just freaking touch it and clean that up. Because we got to clean up this area that's punched inwards a little bit, cracked inwards. We got to do that. It's an imperative. Yeah, I'm going to make it look like that as far as the inside goes. I guess the only way we're going to find out is to bounce the camera around and completely ruin the shot. I hate it when I ruin my shot. So here we go. Let's some more light on it so I can see. Let's see, we'll run, I'm just going to run 600 RPM. This doesn't have to be anything cray-cray. Looks like it's running good. Running well, sorry. Tailstock is locked. I think the only thing to do is to just try and clean that up. So let's give it a shot. I'm just going to use the inching button. Well, I know you can't see nothing, but when I put a light in there, which is not going to help you at all because it flickers, it looks pretty good. Let's see if we can readjust this one. Right there, there's a shiny spot. Just look for the wet spot. You can see we just touched that. And it looks pretty good. Looks like we've cleaned it up. So the real test here is, how does this jet go back in? Because the way that thing was going in, it was kind of binding a little bit. Oh yeah, it feels perfect now. I don't think we need to do any more than that. As far as cleaning up that inside, that actually looks really good. So just touching it with that 5 mil end mill is going to work. Now I need to take this back out. We're going to have to put it back in later, but all we're going to need to do is face that lightly, because my intention is to solder this. And if we can solder it, then I'll solder it with it kind of on its side like this, so it doesn't want to run inside of it. And it'll fill that crack up a little bit. Just touch the face with a regular facing tool. Just touch it to square it off. And then use a hand file to take care of any irregularities with the hex. And that should solve this, but my main concern was getting this, this crack, this piece of material that's been pushed inside toward the threads out of the way, which that accomplished handily. So if you take a good look at this, close look, and it does look good. That cleaned it up perfectly. Couldn't ask for anything better. So there's your spot. And if you kind of angle it this way and look down in there, you can see that crack does extend into the threads a little bit. And the threads, again, don't seal this off. That shoulder does. So, would it make a hill of beans, significant or hill of beans a difference on the running? I don't know, but I know it's not right. And you can see that this is nothing I did. I probably should have mentioned that before, because, that spot that's folded over is crusty like the rest of the jet. So, but I would say that this is a removal apprentice mark, considering the angle it's at. So it's kind of angled out that way up. That's my guess, at least. So I need to set this up and figure out how I'm going to just get a little solder in there. So I figured, why not just hang it in the other drill press so I have the threads down, because my objective here is to get a pencil to point with here. It's amazing I have one of those. My objective here, because this is where the damage is to hit this with solder and let it run down. Now it's going to run down and blob on this outside face, which is exactly what I want it to do. And it'll wick inside that little crack. It'll be wicked, man. So since I have a little witness mark right there, I can just concentrate solder. And what I'm going to use is electronic solder, but it's rosin core silver. It's actually silver bearing rosin core. solder. So it's actually pretty good for this kind of stuff. And I don't need much. I don't need to do anything heavy. Heavy, dude. So we'll just clean it up again with some brake clean, even though I already have cleaned that brass with Scotch Brite, you know, a greenie pad. Get the corrosion off of it. I figured that the other Grizzly will be perfect for this. And I can't chuck it very tightly, but I don't want to damage it. The Jacobs chuck on that is about worthless anyway. So anyway, is it even a Jacobs? No, it's not even a Jacobs chuck. No wonder it's worthless. It's some freaking Chinese piece of crap. We'll get a little bit of this on here. Some flux. You ever have a Fluxer Nutter sandwich? It's pretty good. Go look it up. It's a real thing. I'm going to use a pencil dick torch because I don't think I need any more heat than that. I'm sure it'll be a huge failure and I'll probably melt the phone. There we go. Just don't think we're going to need any more heat than that. About it. Let it cool and see what we got. Didn't blob around as much as I wanted it to that way, but I think it's probably okay. Not entirely happy with it. I think too much heat's wicking up. I'm gonna go ahead and hit it with the big torch on low. I think that came out pretty good. It's just, let me put it this way, it's just along that edge we just cleaned up with that end mill. I can't guarantee 100% it's you know, penetrated or kind of capillary filled in the crack, but it rolled over the bottom edge is what I wanted to do, so we can just face that lightly, and we're just gonna have to hope for the best. So we just gotta take this blob off on the side, and I mean, we don't have to, you could leave it, but why would you? You know, I mean, it's not gonna do any harm inside there. I don't know, might just take some of it off and leave a little bit of that extra solder on the outside of this because, you know, there's plenty of other parts of the hex to grab. I don't think there's any space limitations, so, but we definitely got to do the face. So I'm just going to, off camera, take care of this with a file and the vise over there with some soft jaws, and then we'll put it back in and do this part. And I think it's about the best we can do. Okay, we're back at the lathe, and we're going to go ahead and just face this. We don't have to re-indicate this in. You don't have to indicate for facing. Who cares if it's running out a little bit this way? We just need it to be nice and square this way, which we're going to have to assume because we really don't have a way to test it. But, you know, I built this, so I'll take full responsibility if you screwed it up. Now, what we want to do here is just take this booger out of here, you know? So we'll come up, we'll sneak up on that. That'll be our high spot. And I'm putting a little bit of magic marker there because I can't find my blue one. And I think I know where it is. And probably in my other pants. I leave a lot of stuff in my other pants. Just ask my wife. So now what we're going to do here is just bring this thing up close. Make sure it's, you know, just snug in the in our little secondary vise here. And then we're good. I just don't want it to spin. You know, if that happens, we may really screw it up. You know, I don't like spinners in that regards. Other types I do. Okay, so close enough. We'll run 800 on this one. No reason to go cray-cray on it. And here we go. It's actually pretty good. Light sucks. Oops, too much. Really want to sneak up on this. Set the Z and we'll just move in like 2 thou at a time. Got the freaking DRO, might as well use it. We are touching a little bit around that now. You just wiped off the magic marker, so I'd say we're there. And I left some of that booger on there just to thicken up that area. I'll show you here in a sec. Just to thicken up the area around the top where it's cracked. I kind of tapered it in, you see? Kind of filed it in like taper. I'm going to use a little bit of sandpaper and clean it up better, but now we got a nice true surface right there. See if we can zoom you up a little bit better on that. Yeah, perfect. We didn't take anything off. If anything, we took a couple of tenths up to 1 thou, and that's it, which will be perfectly fine. And it's got a little bit of meat there. We'll just use the other parts of the hex to tighten the thing up, and in the carburetor body, and Bob's your uncle, I think we're good. I'm finishing number 4 carb now. I'm fixing to do the slide. The interesting thing was I talked about the carb screws in video 1, and looky what I found. I found a pack of brand new Valkyrie original carb float bowl screws from Red Eye Tech that I didn't use on the last job because, and I forgot about them, those screws were like brand new in themselves. So I said, why charge a customer for something and that he didn't need at that time? So I just kept them. So we're going to use them for this viewer's carbs, and they work out really well. I did test the float bowl, and the needle was coming right back down, and I thought, what the hell was going on? But it turns out it's my freaking piece of crap vacuum pump. Once I was able to get it to pump up over 10, it held at 10 inches of mercury, and I could flip it upside down, and no problem like I normally test them. So you've seen that in other videos. I'm not going to go into that too deeply here, okay? Make sure you tighten up your drain screw when you're done, so when you test them, it doesn't flow fuel all over the place. But as far as these slides go, what I wanted to just show you real quick, and I've already done it on this one, is you take one of the screws that comes off the caps that holds the slide cap in, diaphragm cap, put it on here, and you got to pull this pretty hard and wiggle it around. And I'll show you on this one because I've already put one in. It will come out, but they're very tight. And then you put a new O-ring on that, which I've already done. You can take your needle out, which I've already done, and clean it. There's a washer underneath it. And then to put it back in, you just reverse the process, put a little silicone grease on it, stick it down in. It clicks in. Take the screw out. There's a spring in there, so make sure that spring is still there that keeps pressure on the needle, sticking downwards. Then clean this thing up real good, which I've already done. And we can insert it into the carb. So I just wanted to kind of bring that up because you can use those screws to pull that out. I guess it's an M5.8 thread pitch, I guess, or 0.08, whatever the case may be. And by the way, I did look up the springs. They are all the same, so we don't have to worry about any differences there, like I mentioned on the older Sabres Magnas, like my Magna. So then we'll just put the cap on, and this carb is pretty much done because we're pretty much out of parts here, so that's good. So put your cap down and hold it in place firmly. Make sure that the diaphragm seal is even around in there, but do this. And you hear that, and you feel it kind of restricting because it's pushing the diaphragm up and pushing the air out different orifices and different ports. That's the proper sound. You want to hear that. So pretty much ready to go, but what I'm going to do is I'm going to do one more test. I'm going to do a test here that I haven't done before, but I got to go make something to do it with. So let me do that and I'll come right back. All right, so my idea here was bang something like this out, which is an exact duplicate of this end of the aluminum ones that I made. That'll be the ones that are going in these carbs, just to test the carbs individually. Now, obviously it doesn't test the whole fuel rail, which we'll do once they're assembled, but what it does test is the float valves. So I can isolate each carb, because remember, on the last 2 Valkyrie jobs, these 18-8955 K&L float needles, float valves, you know, they didn't work. And the float level was very high. In other words, the float was very high up, which would have resulted in a low fuel level. On these carbs, though, from what I can tell, I can't really 100% identify the float height. I mean, I just can't find it very well. I found some references that it's the same 13.7 millimeter, and that's what these are. They're, you know, by eye with a scale, they're around 14, so probably 13.7. So let's just test each one, and that way we'll know right now if there's any problems with these. And if they all pass a pressure test individually, then they're going to pass a pressure test in a complete unit. You said unit. So what we're going to do is just plug that one in. I don't remember what number carb this is. I don't think it really matters. And there's 4 psi. And she's holding pretty damn good. Remember, a little bit of degradation is not a terrible thing because they're not designed to restrain air, you know, to hold back air. They're designed to hold back a liquid. You know, what we can do also is do our little trick. I mean, I blew the dust out of them, but sometimes you need to do this anyway. That's not terrible at all. So let's go, what number was this? This is number 4. This is number 1. Again, that's not terrible at all. It's holding pretty well at 4. That's about what I expect. I'd call them a pass. This is number 2. This is the one that's got that little problem in the bore here. See how this one reacts to that. See, that one's dropping down quick. Uh-oh. Let's try a different part of that bore and see what happens. No, maybe we got a little dust in there or something. Well, let's go ahead and spray a little soapy water over here and see if it's that leak in there. A little soapy water right at that joint and see what happens. No, it's definitely not leaking there. Okay, let's move on to the next one. What did we test? 3 is really good. But 2 is giving us a problem under the same circumstances. So maybe we got a little piece of dirt in that seat that I didn't see before. Let me pull these off. That's why I'm doing it now. Let me pull that off and see what we got. Okay, let's pull that float out. Maybe there's a little piece of dust or something in there. It just didn't come out. I mean, that's all it takes. Let's test that bore itself. We'll just put our finger over this and we'll pump it up. Yeah, there's no problem with this, luckily, so I think our fix is going to be fine for that little rough spot in there. Let's get a different float needle because, you know, manufacturing variances, luckily I have extra ones right here, in fact, because they come in packs of 6 and I didn't use any of them, so I'm only using 4, and I had actually had 2 more in another pack, so same test with a different float valve. So if I hold pressure down on it, it definitely stops it. You see that? There's like a little fiber on that needle. And I didn't touch the thing. I took it out and just laid it down, so. This is number 2 that had that other issue, so who the hell knows? Sometimes carburetors have just these weird problems that can't necessarily be explained by any other explanation or causation as the fact that they're just old. I don't know what the deal with that is, but sometimes they just behave weirdly. Yeah, that's better. That's about where the other ones are. Because the higher the pressure, the more it's going to want to push past that, that float valve. I mean, it's not exactly as good as the other 3, but there's really not a whole lot more I can do with it. We'll just have to try it with fuel. Hopefully it works with fuel. It's not bad. I mean, I've seen worse and they worked. That's got a pretty good... I mean, it's got decay, but it's not terrible. Yeah. So we're going to have to try it when it goes all back together, and then as a unit. But the only other option is if we have a problem is we're going to have to order the OEM float valves. And I'd rather do that while these things are not racked up because they're easier to get the float bowls off in this position. Of course, we got new screws, so maybe that mitigates that. Okay, now curiosity has really gotten the best of me here. And I'm going to take one of the old plastic fuel tees, put another one of these Viton, same O-rings we're using to test it, that you just saw, and the one we're not going to necessarily use those on the final product, but we'll probably use the Honda OEM one. So we put an adapter hose on here. We'll just hold this there. Let's shove this in, and I bet you it's going to hold just fine. I mean, as far as that location. So pretty much the same, yeah. So, but if we move this around just a little bit, you see, and that really blows out of there. Now this thing is not going to be moving around in there, but now all we're doing, let's put a little soapy water in here and try that. We'll just hold this. This is not easy to do. You see? Right there? That was my concern. Let me zoom up on that and see if I can get you a better shot. Now naturally these are going to be perfectly stationary with the exception of being able to rotate, but that's a new O-ring. And that's number 2. Of course, it pushes itself out because it's got back pressure. So I gotta kind of hold this, kind of fiddly doing it. All right, I got a cap on it. This is just too fiddly to do it this way. I got to be able to hold the thing in from moving out, you know, pushing itself out. So we do, you know, if I hold it still, you can see we've got some bubbling coming out of there with that O-ring. Now I could pull a Honda O-ring out, but you know, they're pretty much the same. I think these Viton ones are just as good. So that bore, I think, would have given us a problem with OEM rings and possibly given us a problem because remember, this thing has got some end play on it. So who knows where this thing is going to be sitting. If it sits right there, you see how it's bubbling? That's because it's in that little spot. So it's coming out from right here. So in this position about 3, 4 o'clock. And that's exactly where that little area is in the bore. So that is definitely going to give us a problem with something like this. Let's go ahead and repeat that with this one. This one's a lot stiffer. We didn't get it before, but never know. But we can wiggle this one around pretty much, and we don't get any bubbling whatsoever. So that really proves that out right there. I mean, I'm not pulling your leg on this one. I mean, that proves it out right there. This one's got, what, 4 PSI in it now? 4 or 5? But even if you put it right in there where that spot is, I'm not getting any leakage. But again, when I do this guy, which is the original T and a new O-ring, the Viton O-rings, I'm not sure how the Honda ones are going to behave differently. I don't think they would. What am I doing? Do this one again. You can feel it's definitely not as much pressure going in like that. And we get leakage. So remember, again, this is the main point here. This thing can move back and forth significantly because it's about 60 thou, 30 on the side movement of this thing in an axial fashion or side to side. So who knows where the thing's going to be sitting when it goes in finally. You know, final. If it's doing that, in that position, then it's going to leak. And again, it's coming right from that 3, 4 o'clock position, and that's exactly where that little area is. I'll show you that, so you don't think I'm lying. But there's that area again, right there, right about there. That's where we're getting the leak from. I'm real pleased with that. I think they're going to pass a pressure test when racked together, no problem, especially with these guys. If I have to make any final adjustments, I'll do that off camera as far as facing this back or something. But I think this was a good idea to make these. It was the only thing I could think of to compensate for this damage in that bore. There's no way you're going to be able to use some sort of sealant or something, because what happens is when these things go in, you're not really sure where you're going to be able to have to clock them. They have to be able to turn. Especially in our situation, there's not a lot of room in there, and I'm using straight fuel line. So I'm going to have to do some shenanigans in there to get this to actually work. All right, so I'm going to clean up, and then we'll start the video back up when I get the O-rings in for the air cut valves so we can get them installed. Since they're all tested and passed, we don't have to mess with those. We'll just install them, and then we can get these racked up, which we'll probably do a time warp. For some reason, it looks like I was bumbling and fumbling through it. Well, let me tell you right now, the reason why is because I was. I was bumbling and fumbling through putting these carbs back together. It's been a while since I took them apart with all the stuff going on around here, and I just had to kind of feel things out before I could get them back together, but I wanted to at least give you something. Now, I'm going to show you something that I figured out just toward the end of bumbling and fumbling through these. That'll make your life a lot easier if you're re-racking these types of V4 Honda carbs. Set them up with the intakes up like this. I think that's the best way to do it. Whether you have 1 and 3 toward you or 2 and 4 towards you, it does not matter. Next thing you want to do is you want to start with 1 and 2. Now for 1 and 2, you need to put the fuel T in, sort of. If you have ones that you made like this, definitely. The originals will go in that way because they fit in through a little space down in here. So I had to put this one in number 1 and go in this way. The fuel T for number 2, or say between 4 and 2, will go in that way because that shoulder is on this side of it. Speaking of this side of it, there is no spacers between the carbs that are on this side. They're all on the 3 and 4 side, which helps you out immensely. Now you're going to need those spacers to do what I'm about to describe to you, because the spacers have little pins in them, like locating pins. The ones between 1 and 3 and the ones between 2 and 4. The one between 3 and 2 down in here does not, so you don't have to worry about that. But you want to put this one in, and through all 3 of the studs. Take the nuts off this side, leave the nuts on this side, the 1 and 2 side, put the studs through. It'll start lining things up. If you have that fuel T in, all the better. You don't need to put anything else in at this point. Now at that point, what you can do is you can start feeding stuff into the 1 and 2 carb, using the studs just to kind of hold things in position. These little pins will help lock it into the bracket. And when it's locked into the bracket, then that really keeps things oriented. So once you got that done, you're pretty much 3/4 of the way there. So you start feeding your stuff in, like your vent tees, the big old Famunga vent tees with the big hoses. Remember, you have to put your linkage on. The linkage is not going to be a problem for you though, because the linkage goes between 1 and 2. It does not cross carbs. So once it's in, you want to do the one for number 1 before you even rack the carbs up at all, because it's easier to get at. And then this one we can get at really quick. I'm about to put the cotter pin in this one, in fact. So that one is just going to go together and stay there, and you don't have to worry about it once it's slipped over the pins it goes on. So once you get to that point, again, you can start moving stuff in from this side, from the 3/4 side. Those studs sticking out as kind of an alignment. It aligns everything up for you when you start sliding stuff over. Then all you have to do is reach in here and move around the little pieces like the T's and the vent T's and so forth, to get them to line up to the hole that you need to get to. Then you need to just pop them together, and then Bob's your uncle. It's pretty much done. Definitely work from this side. Consider it, I got gas. Consider it this way. So if I hold a piece of construction paper up and eliminate 3 and 4 from your view, you're going to be dealing with this side alone to start with. And with the exception of that fuel T, you can pretty much get everything going in this way. And with the original fuel T's, you can get them going in that way because, again, this is slotted out for that. So I think that'll help you a lot to do it that way. So once you get all these things slid in from this side, you have to do number 3 first, because 4 goes on the outside of number 3. But that's what I would do at that point. I do 1 and 2, then I do 3, line all that stuff up. Then I would do 4, line all that stuff up. Now everything's going to pop together and be where it's supposed to be. Don't forget this little bracket up in here for the enricher. I did forget that the first time, and I didn't understand why these things seem to have a space right there. That's because that goes there. Essentially, the spacer is cut down a little bit to accommodate for that. And then everything's going to go together just fine. Then put your nuts on, at least snug them up, and test everything out. Make sure your fuel tees are not jammed up. It's got to go this first, then this, that way. I hope that helps. And what we're going to do now is I'm going to go ahead and get the cotter pin in. I've already tightened up the nuts really tight. And since it's upside down, let's get some fuel hose on. Let's pressure test it and see how we did. The main challenge I had was running the fuel lines, at least the way they were. So I'll show you that first. This I'll talk about here in a minute. There's a separate video on this, so I'm not going to go into it very deeply. That explains the whole story, but it will give you kind of an overview because it pertains to what I'm about to tell you here. So as far as the 1 in 3 carb fueling that goes to the T is like this. It came in on the end with a very sharp turn and coming out the left side or the one side like this one is here. That went underneath, essentially like this, at a slight angle coming out underneath this big vent right here. That is the outside vent for this venting system, whatever that goes to on the bike. And then it attached again on the end of this, so it kind of came out diagonally. So that was pretty easy to replicate because it's a fairly straight shot. If I had a T that had a straight fitting or two straight fittings, and kind of see where I'm going with this, rather than one at 90 degrees to another. So let's move on to 2 and 4. Now the 2 and 4, here's the original, you can tell because it says original on it, it went down and under like this. It went under the 1 in 3 fuel joint and up very sharply into the 2 and 4, excuse me, fuel joint. And this is essentially the angle it would have been at. 1 in 3 would have come out kind of at an angle, and these would have sort of crossed each other, but at different heights. Because the 1 in 3 was on, well, there you go, now I just dropped it. Because the 1 in 3 was on the back side of this inlet T. So I couldn't do this because this hose is really bad. You can see it's cracking at the end. So my idea was, number one, you already saw how I've done 1 in 3, it came straight out, and as long as I have 2 straight fuel fittings, that works. The 2 and 4 was the one that gave me the most problems because I wanted to replicate this. I wanted it to come around and come over the top and then come down and then attach to this distribution T. But I originally made this distribution T, which you'll see in that video if you watch it. You know, if 3 or 4 of you watch it like it normally happens, you'll understand what I'm talking about. I originally made it just like that, where it was straight and parallel as far as the outlets. But then after I thought about it, and you'll see it in that video, I said, you know, I'm going to have to make them so they're different, like one going down and one going up, because this actually comes in from the top. So I figured out a way, which you'll see in that video, to cut this in half with precision using the lathe. And I made this little brass spacer and then left it separated in anticipation of finding that clocking position. And then I'll press it together with 638 on this side, and Bob's your uncle, it's done. I tried doing that. I didn't press it together, but I tried figuring out how I could get a piece of regular Motion Pro hose to do this, and it just wouldn't work. It was too tight. It was potentially going to kink. So the only way I could do was go straight in there, but the trouble is the clearance is very, very tight to the throttle linkage, which is difficult to see. You see that little brass thing right there inside there. I'll point to it in editing. Said I just have to hold the hose up, secure it up, which I've done with a wire tie on the top to keep it as far away from that linkage as possible. And I also use some, it's really pretty heavy, thick-walled, heavy-duty shrink wrap on the hose itself. So now that's protected where it could potentially rub and chafe. And I just got one wire tie right there loosely to hold on loosely, but don't let go. And that is not going to let go. So that kind of holds everything up out of the way. If I had the molded hoses, this would have been a no-brainer with this, but you can't get them. They're absolutely impossible to find. That's the best we can do, so we're going to move on. I came up what I think is a much better option on that hose that's too close to the linkage. What I did was I made a little clip that slips over that center bracket. That clip comes from Dad's old bench. These guys that you screw in with that one screw in the center, and you can hold screwdrivers, or you can hold, you know, whatever you want in it. So who knows how old this is. So I had a couple extras, so I cannibalized one because, you know, it's got this little feature where if you cut it off here, it's got a little thing that'll hook on a flat piece, and just kind of worked it, heated it and worked it to bend it up into a curve. I put some heat shrink tubing on it to kind of give it a little protection to the hose itself. So I think that works really well. It looks a hell of a lot better than it did before. It's not kinking the hose. It's protected. The hose is protected on the metal with a, like I said, a piece of heat shrink on there. I'm going to go with that. I think that's the best way to do it. It's not going to come up. There's no way it can come up because the hose wants to flex downwards. And so we're gonna leave it with that. We got plenty. Well, we don't have plenty. Clearance is clearance, as they say in the machine world, machinist. And we do have enough clearance down in there where it's not even touching, but it's very close. I'm not gonna lie to you, it's close. But it can't physically drop, where I thought with this being not so tight, it might be able to move around. So I think that's gonna be the best way to do this, and that's how we're gonna leave it. Hang on one sec, I'm thirsty. All right, folks, I'm with you now. These are all done. This is all done, yeah. These are all done. I'm real happy with the way they came out, and I think the viewer is going to be equally as happy for this. What is this, an RC36 or something? I don't know. 96 VFR750F, these Cayenne carbs. Learned a few things because I'm not terribly familiar with these, and I've already kind of gone over them in this video. My suggestions to you as far as reassembly and disassembly from video 1. So you put those two together, I think you'll be pretty well set to do a rack like this if you so need to do or so choose. So as far as this little T goes that I showed you before, there is a separate video on that which will come out after this one, because if I put it out before, it probably wouldn't make much sense. So I'll go over the details on that and machining it in that video. The only point that I'll make here and make at the end of that video, because I haven't finished filming that as well, is I didn't need to split this in order to be able to clock it, obviously. I thought I was going to have to do that. So I guess that one lesson that I would want to illustrate at this point is don't count your chickens until they're hatched. You got to make sure that you know what you got before you actually do modifications to a part or something like that that's being custom made. And I didn't do that, so it's still going to work, but lesson learned. So if you like what you saw, you know what you need to do. Stick around, ring the bell, share, like, subscribe, and you get notified when I put more crap like this up. You know, I think I'll put this down now before I drop it, because I drop a lot of stuff. And I'm just going to finish up by saying thanks for watching. As always, don't just repair, restore. And we'll catch you on the next video.